So in the last part of the DR, questions 1 through 7, we talked about kinetic energy. This time you're going to go to week 2, and I've moved that number 1 assignment over to week 2, and you're going to finish up that DR. Go to your attachments. I'll have another video there for you to watch, which will be this video. And you're going to do the reading, which I'm going to read with you right now. But obviously you're going to be doing the what is energy directed reading. And you can see that there are 32 questions, which I think you can do. So let's start with the reading. You're going to go to page 126. So we already talked about kinetic energy, and kinetic energy is energy in motion. The other type of energy is called potential energy. And potential energy is energy that is stored and usually is a result of an object's position, like how high it is above the ground. So the higher an object is above the ground, the more potential energy it has. So let's read together. Not all energy has to do with motion. Potential energy is energy of an object has because of its position. For example, the stretched bow shown in figure 3 has potential energy. The bow has energy because work has been done to change its shape. The energy of that work is turned into potential energy. Gravitational potential energy. When you lift an object, you do work on it. You use a force that is against the force of gravity. When you do this, you transfer energy to the object and give the object gravitational potential energy. Books on a shelf have gravitational potential energy. So does your backpack after you lift it onto your back. The amount of gravitational potential energy that an object has depends on its weight and its height. Calculating gravitational potential energy. You can find gravitational potential energy by using the following equation. Gravitational potential energy equals the weight times the height. Because weight is expressed in newtons and height in meters, gravitational potential energy is expressed in Newton meters, or something called joules. Recall that work equals force times distance. Weight is the amount of force that you use on an object to lift it, and height is a distance. So, gravitational potential energy is equal to the amount of work done on the object to lift it to a certain height. Or you can think of gravitational potential energy as being equal to the work that would be done by the object if it were dropped from that height. Height above what? When you want to find out an object's gravitational potential energy, the ground that you measure the object's height from depends on where it is. For example, what if you want to measure the gravitational potential energy of an egg sitting on a kitchen counter? In this case, you would measure the egg's height from the floor. But if you were holding the egg over a balcony several stories from the ground, you would measure the egg's height from the ground. You can see that gravitational potential energy depends on your point of view. So the height you use in calculating gravitational potential energy is a measure of how far an object has to fall. Another type of energy is called mechanical energy. So mechanical energy is just kinetic energy plus the amount of potential energy. How would you describe the energy of a juggler's pins in figure 4? To describe their total energy, you would state their mechanical energy. Mechanical energy is the total energy of motion and position of an object. Both potential energy and kinetic energy are kinds of mechanical energy. Mechanical energy can be all potential energy, all kinetic energy, or some of each. You can use the following equation to find mechanical energy. Mechanical energy equals potential energy plus kinetic energy. Mechanic energy in a juggler's pin. The mechanical energy of an object remains the same unless it transfers some of its energy to another object. But even if the mechanical energy of an object stays the same, the potential energy or kinetic energy it has can increase or decrease. Look at figure 4. While the juggler is moving the pin with his hand, he is doing work on the pin to give it kinetic energy. But as soon as the pin leaves his hand, the pin's kinetic energy starts changing into potential energy. How can you tell that the kinetic energy is decreasing? Well, the pin slows down as it moves upward. Eventually, all of the pin's kinetic energy turns into potential energy, and it stops moving upward. As the pin starts to fall back down, again, its potential energy starts changing it back into kinetic energy. More and more of its potential energy turns into kinetic energy. You can tell because the pin speeds up as it falls towards the ground. Now there are some other forms of energy. Page 128. Energy can come in a number of forms besides mechanical energy. These forms of energy include thermal, chemical, electric, sound, and nuclear energy. As you read the next few pages, you will learn that these different forms of energy have to do with kinetic and potential energy. Thermal energy. All matter is made of particles that are always in random motion. Because the particles are in motion, they have kinetic energy. Thermal energy is all of the kinetic energy due to random motion of the particles that make up an object. As you can see in Figure 5, particles move faster at higher temperatures than at lower temperatures. The faster the particles move, the greater their kinetic energy, and the greater the object's thermal energy. Thermal energy also depends on the number of particles. Water in the form of steam has higher temperature than water in a lake does, but the lake has more thermal energy because the lake has more water particles. Where does the energy in food come from? Chemical energy. Food is made of chemical compounds. When compounds such as sugar form, work is done to join the different atoms together. Chemical energy is the energy of a compound that changes as its atoms are rearranged. Chemical energy is a form of potential energy because it depends on the position and arrangement of the atoms in a compound. Page 129. Electrical energy. The electrical outlets in your home allow you to use electrical energy. Electrical energy is the energy of moving electrons. Electrons are the negatively charged particles of atoms. Suppose you plug an electrical device, such as an amplifier shown in Figure 6, into an outlet and turn it on. The electrons in the wires will transfer energy to different parts inside the amplifier. The electrical energy of moving electrons is used to work that makes the sound that you hear from the amplifier. Electrical energy used in your home comes from power plants. Huge generators turn magnets inside loops of wire. The changing position of a magnet makes electrical energy run through the wire. This electrical energy can be thought of as potential energy that is used when you plug in an electrical appliance and use it. Sound energy. Figure 7 shows how a vibrating object transmits energy through the air around it. Sound energy is caused by an object's vibrations. When you stretch a guitar string, the string stores potential energy. When you let the string go, this potential energy is turned into kinetic energy, which makes the string vibrate. The string also transmits some of its kinetic energy to the air around it. The air particles also vibrate and transmit this energy to your ear. When the sound energy reaches your ear, you hear the sound of the guitar. Light energy. Light allows you to see, but did you know that not all light can be seen? Figure 8 shows a type of light that we use but can't see. Light energy is produced by the vibration of electrically charged particles. Like sound vibrations, light vibrations cause energy to be transmitted, but the vibrations that transmit light energy don't need to be carried through matter. In fact, light energy can move through a vacuum, anywhere where there is no matter. Nuclear energy. There is a form of energy that comes from a tiny amount of matter. It is used to generate electrical energy and gives the sun its energy. It is nuclear energy, the energy that comes from changes in the nucleus of an atom. Atoms store a lot of potential energy because of the positions of the particles in the nucleus of the atoms. When two or more small nuclei join together, or when the nucleus of a large atom splits apart, energy is given off. The energy given off by the sun comes from nuclear energy. In the sun, shown in Figure 9, hydrogen nuclei join together to make a larger helium nucleus. This reaction, known as fusion gives off a huge amount of energy. The sun's light and heat come from these reactions. When a nucleus of a heavy element, such as uranium, is split apart, the potential energy in the nucleus is given off. This kind of nuclear energy is called fission. Fission is used to generate electrical energy at nuclear power plants. That is all for the reading. Thanks.